Okay, before we get started, anybody have questions? Anybody have questions on anything? Anybody have questions? Okay. Again, I would assume from looking at the homework, most of you don't seem to be having trouble with that, but if you do or you're stuck anywhere, by all means, feel free to hit that message instructor link at the bottom and just let me know. Okay, I'd be happy to work through problems for you. Okay, so as I said, what we're going to be doing today is going through a practice exam. Okay, I'm going to start by sharing my browser with you. Okay, and show you where we are in the course. Nope, hold on. Sorry, this takes a minute. Okay, if I have to, I will just open another tab. Here we are. Okay, we're in week 13. Okay, and we did the z-scores and normal probabilities last time. What we're going to be doing today, and there's no notes page for it, because again, what I had to do was print off my version of this Unit 3 practice exam. Okay, take a look at this practice exam. It looks a lot like the real exam, namely, it has the same number of questions, 20. Okay, and again, it's not timed, but it basically tells you to, try to do it in 3 hours because that's the amount of time you have for the real exam. Okay, so nobody's asked me that yet, so I'll just throw it out there. The exam itself, Unit 3 exam's got 20 questions on it, and there's a 3-hour time limit on it. As always, try the practice exam. You can run this as many times as you need to up until May 2nd. Again, it doesn't count in your grade, or I should say it counts the same in everybody's grade for 20 points, regardless of how you do on it. Okay, so give this a shot. I would definitely recommend before you do this one. This one you will only be able to open once. Okay, so try the practice multiple times, and again, the real one just once. As always, if you're able to write down what you did, even if you use the calculator, okay, just give me a quick idea of what you typed into the calculator, all right, in the work, and then upload it to this assignment. Okay, that way, if I can give you partial credit. Okay, if I have no idea what you did, it's kind of hard for me to, hang my hat on, well, I think you might have done this or you could have done that. Okay, show me something. Okay, even if it's just a one line. Here's what I typed into my TI-84. Here's what I typed into the online calculator. Now, there is no lockdown browser on any of our exams, so what I expect you to do is either use your TI to do the the descriptive statistics and the normal stuff. Okay, and again, if I scroll down past the final exam, I just want to make sure everybody sees this. Online tools and calculators. Here's probability calculators. Here's statistics calculators. Okay, so if you don't have a TI-84, use this stuff. Okay, remember, you've got an Office 365 login. So if you're comfortable with Excel, by all means, use the features built into Excel. It has descriptive statistics built in. You can find a mean and a median in Excel. You can do frequency distributions in Excel. And again, hopefully I can demonstrate some of that as we move along. Okay, I'm going to leave this open here. And again, I'm just going to open my printout of the practice exam. Okay, so give me a moment while I do that and share it with you. And as always, if you have questions while we're going along, either unmute yourself and ask, or just put your questions in the chat. Okay, and let me share this document with you. Okay, so everybody should see my Unit 3 practice exam. Okay, this is kind of the directions that are going to come out at the front. Try to get it done in 3 hours. That's the amount of time. And again, this won't count in the sense of it won't depend on how well you do on it. Everybody will get the full 20 points. Okay. All right. So question 1, determine the mean, median, and mode of the following data set. Again, do not do it by hand. Okay. You have a couple of ways to do this. All right. I'll show you at least one of those ways. Of course, you can bring up your TI-84. And again, I'm going to do that here and share that content with you. All right, so everybody should see my TI-84. One thing I can do here, after I turn it on, is I can put these data in a list, okay? And again, you get that from stat, edit, okay? And again, you can put the data in a list. Okay, so let me just quickly show you that. And again, the biggest thing people do wrong here is make typos. Okay, so please check your data after you type it in. Okay, so I'm pretty sure I have 10 data items here. There's 5 in the first row, 5 in the second. My calculator is looking for me to enter the 11th, so I'm sure I didn't miss one. Okay, I'm going to quit out of here. And then if you go into stat calc, the very first one is one variable statistics. Okay, so I'm going to hit that. Okay, I don't have a frequency list here. Okay, I just have individual scores. So I'm just going to go down and hit calculate. And it tells me, again, my mean is 107.85. Again, you have to remember that X bar is your mean. Okay, that's your sample mean. Okay, the median, if you scroll on down here, this little arrow means there's more below. Okay, remember I talked to you briefly about quartiles. Okay, quartile 1 is your 25th percentile. So with quartile 1 meaning 99.9, what that means is 25% of your scores are below this value. Okay, 25% of your scores are at or below that value. And again, I think you can see the 2 that are below the value. Okay, your median is your 50th percentile. Okay, see it right in there. It's usually called quartile 2 or median. So I'm going to put 105.5 here. And then quartile 3 is like your 75th percentile, right? So 75% of the scores are below 122. Okay, and notice this doesn't tell you a mode. Okay, so you're kind of stuck with looking at the data to see if any of the data items repeat. Okay, so if I'm looking at these data items, I'm looking and I'm seeing the 122 appears twice, 3 times actually, and it's the only data item that I'm seeing that repeats. So my mode is 122. Okay, if you had a lot of data items, one thing you could do is you could sort the list. Okay, and again, that's something that's, if you go to list, second stat, okay, you see ops. One of them is sort ascending, sort descending. If you sort the data, it's not going to affect any of the statistics for the data, but you'll be able to see repeats of the same data items. They'll be clustered. Okay, that's the only way I can see to do it easily. Okay. Now, again, I've also, if you don't have a TI-84, okay. Oh, and by the way, if I were rounding to the nearest tenth, this would be 0.9. Okay. Right, so it says, again, round answers to the nearest hundredth. Oh, it says hundredth. I'm sorry, I thought it said tenths. Okay, and the others are exact the way they are, so it shouldn't be a problem. You don't have to pad these out with zeros, okay? As long as they have at least two decimal places, two or less decimal places, you'll be fine, okay? So if you don't have a TI, if we go back to our Canvas course, okay, you can see I have a descriptive statistics calculator in there. And again, you could enter your data here. Again, you can type each number on a separate line like this. Just hit an enter in between. Or you can put them in with commas, however you prefer. Okay. Now here's the good news. If you have your exam open, okay, in one window, again, I can't do it with the print that I have of the exam because it's a print of the exam. It's not the actual exam. But one thing that you could do, maybe I can open the actual exam and show you this because this is kind of cool. All right. So here is my Canvas course. Let me go to, give me a minute to get back down to where I was. Okay, so here's my test, my practice exam in week 13. Okay, so if I'm going to go into this one, okay, hopefully it'll let me do this in teacher view because I'm not actually taking the exam. I want to just show you, right? See these data? Okay, I can do this. Select them, highlight them. I'm saying highlight, and then I can do a Control C to copy them, Control C on a Windows computer, right? And then if I want to go to my descriptive statistics calculator, I should be able to do a Control V and paste them, all right? Now, I might have to do some nonsense like this, like put them all on a separate line, like this, but at least I didn't have to type all the data in, okay? So you can see that's an easy way to do it, okay? Okay, another thing you might want to do is if it's like in a table, you might want to open Notepad or something else. Again, I apologize, Mac people. But there are similar things on a Mac. It's just I don't use a Mac every day. So I'm giving you Windows type directions. Okay. But you should be able to copy data and then, just paste it in the window here on the calculator. Okay. So again, you might have to do a little editing, but you can see the general idea. Again, these data don't match the ones in my review. Okay. Because again, it was from a new iteration of the practice test. Okay. But then you just hit calculate and you would get here, you would get your mean, your median, and your mode. Okay, so they come right out of the online calculator. All right, so okay with using either calculator. Everybody all right with that? Again, I just wanted to show you, you can cut and paste from the exam right into the calculator. It's just because I have a print of my exam, okay, with the numbers I'm showing you, I have to type everything in. Okay, any questions on the calculators? All right. Okay, good. Question two. Question two is again a frequency distribution. So again, this is an aptitude, a musical aptitude test that I can't imagine people have yeah, all right. Let's not talk about how accurate tests are, okay? But basically, the scores go from 0 to 5, but there are certain numbers of people who fall into each category, okay? So this is a frequency distribution, and what it says is 5 people scored 0, 2 people scored 1, 5 people scored 2, and so forth, okay? So if you add up this column, okay, you'll see how many people were surveyed, okay? The frequency column will give you the total of people surveyed. Okay, so if you're doing this on a TI-84, okay, all you need to do is enter everything in list 1, your scores in list 1, and your frequencies in list 2. Okay, so I'm going to just turn it on again. And I'm going to go back to my lists. Okay, I'm going to clear list the clear list 1. Okay, because I had data in that one from before. All right, and then I'm going to go into stat edit. And I'm going to just put the values 0, 1, 2, 3, 4, 5. Okay. And then here I'm going to put in the frequencies, right? 5, 2, 5, 6, 3, and 3. Okay, just make sure that you've got the same number of entries in both. Okay, and then quit out of this, and you're going to go into stat calc, one variable statistics, and this time list 1 has your values, your scores. List 2 has your frequency. So remember, second 2, put list 2 in there, and then calculate. Okay, so this gives me a mean aptitude score of 3.75. Okay, 2.375, my bad. All right, and if you wanted this to 1 decimal place, that would be 2.4. Okay, the median, again, I have to scroll down if I'm doing that, is 2.5. And again, if you've got a frequency distribution, it's real easy to find the mode. The mode is just the data score that occurs the most often. All right, so I'm looking down my frequency column and I see that 3 occurs the most often. So 3 is my mode. Okay, so doing it with a TI is super easy. Okay, if you were doing this, again, your frequency distribution, the one variable stats that I have built into the course will only let you type in single scores. So you'd have to type in 0 5 times, 1 twice. The other thing you might do, okay, is to use Excel, okay, either Office 365, okay, or regular Excel. Okay, so hopefully once Excel comes up, I can share that with you. Right, you could put your scores here, right? So 0, 1, 2, 3, 4, 5. And then you can put your frequencies over here, okay, which are, again, 5, 2, 5, 6, 3, 3, okay? And then what you can do is multiply the score times the frequency, right? So I'm going to multiply this times that, okay? Right, and you can see that that's that way, right? Then just drag it down and it will do that for all of them. Okay, and now you've got a combination of scores and frequencies, and then all you have to do is, again, total these. Okay, so you're going to say equal sum of that range. Okay, so we have 24 people. Okay, then we're going to sum this. All right, and our mean should be this sum, right? So our mean should be this value. Oh, mean. I'm doing it wrong here. Mean tab over equal this divided by that. Okay, and you see we got the same value. Okay, same value in Excel. Okay, so for those of you without the TI-84, it's a little bit more work. I was able to find a grouped one variable statistics calculator, but in playing with it, it doesn't let you it expects you to have bins that are so wide, okay, and it doesn't let you put in actual single values with frequencies, okay? So any questions about using frequencies? Okay, if you're saying, okay, well, how would I find the median, okay, without technology? Okay, well, you'd see you have 24 scores. That means you've got 12 on one side of the middle and 12 on the other side of the middle. So you just count down till you get 12. Okay, so here's 5 plus 2 is 7, and 5 is 12. Okay, so here's 12. That takes you to 2. Here's the other 12 on the other side. So your median is midway between 2 and 3. That's why it's 2.5. Okay, so as long as your data is in order here, you just count down to the middle of your scores. Okay, because again, remember, this is a total of 24 people. Right, so anybody questions on grouped on data? Questions on this one? Anybody questions on number 2? Okay, I'm not seeing any, so I'm guessing everything's okay. All right. This is exactly the same kind of a question. And again, you can see I have my students. Okay, I'm trying to find the average number of students in a math class at Mesa, okay, community college. So here's the results, okay. I have 9 classes with 28 students, 6 classes with 29, 13 with 30, 7 with 31, and 4 with 32. Okay, so I would do the same thing. Okay, I would try to copy these data. Okay, and again, if I'm doing this in Excel, okay, I would put my students in one column and my frequencies in another column, multiply them together, right? Add these up. Okay, and then just divide the total of number of students times frequencies times, divide that by the number of the total of the frequency column. Okay, so again, if I have a TI, it's a little easier because I just have the 2 lists. Okay, so let's turn it on. Where's this? Okay, so I'm going to quit out of here, go into my lists again, clear list 1 and 2, right? Because I have data in those. Okay, and then do the same kind of thing. Again, I'm going to put my data in, there's the first column, so 28, 29, 30, whoops, 31, and 32. And the frequencies I'm going to put in list 2, 9, 6, 13, 7, and 4. Okay, check that they match. Go into stat calc, 1 variable statistics. It's already set up to use a frequency list, so all I have to do is hit calculate. Okay, and again, this is saying, it's not telling me, oh yeah, it is saying up here, round to the nearest hundredth. So my mean is going to be rounded to 29.77. Okay, if I go down to my median, that's 30 on the nose. No need to round that any further. If you look again at the table in a frequency distribution, the row that has the score that has the highest frequency is your mode. And again, remember what range is, okay? I think this tells you your range. I'm not sure. No, it doesn't. Okay, it does tell you how many scores there were though. Okay, so range is just your low value from your high value. So 32 minus 28, the range is 4. Okay, so again, all your data, your scores are within 4 units of each other. Okay, remember, You're finding range on your scores, not your frequencies. Okay? All right, so that's so much for descriptive statistics. Again, I'd encourage you when you take your practice exam, decide what tool you're going to use that you like. Okay, you can use the one variable stats calculator I put in the course. It's just you're going to have to enter 28 9 times. You're 29 6 times, 30 13 times. It's tedious, but it's not impossible. Okay, or just use Excel. Okay, and let the spreadsheet do the work for you. Okay, up to you. All right, so next we have a normal distribution because it tells you it's normal. Okay, it asks you some information about the normal distribution. First, it's asking you where the mean is. Remember, in a normal distribution, your mean, your median, and your mode line up with the bump. Okay, so you've got your mean, median, and mode here. Okay, and that's true for the normal distribution. So I'm just going to put 92 for everything. And it's asking you, what's the standard deviation? Remember that these numbers at the bottom correspond to the scores associated with the mean in the middle. And then this is the mean plus 1 standard deviation. This is the mean plus 2 standard deviations. This is the mean plus 3 standard deviations, right? And going backwards, mean minus 1 standard deviation, mean minus 2 standard deviations, mean minus 3 standard deviations. So in order to find the standard deviation, all you got to do is find the difference between adjacent scores. Okay, so 100 minus 92, that's 8. 108 minus 100, that's also 8. 116 minus 108, that's also 8. Even going this way, 84 is 8 less than 92 and so forth. That means your standard deviation is 8. Okay, questions on number 4? Okay, questions on the basics of a normal distribution? Okay, no? Not hearing any? Okay, this picture is really important for a normal distribution. Okay, so please make sure you understand all the aspects of that type of picture. Okay. All right, they're giving us a single set of scores. We've got 7 of them, and they want us to calculate the standard deviation. We're going to use a calculator. We're not going to do it by hand. I'm going to try putting these data into my online calculator. You can also put this in a list, okay, in the TI-84. Okay, the trick when you do this on the TI-84, make sure you use S for the sample standard deviation, not sigma. Okay, remember we talked about the difference between a sample standard deviation and a population standard deviation. S is your sample standard deviation. That's the value you want to pick, okay, out of the one variable statistics. Okay, if I do this on the online calculator, it's a lot clearer because it actually tells me a sample standard deviation. So if I put my numbers in here, I've got 19, 10, 17, 28, 20, 22, and 16. Okay, I'm clicking sample and I'm clicking calculate. Okay, and I'm just checking. I've got 7 scores. And I go down here and I'm getting S, the sample standard deviation is 5.55. Okay, and it's telling me S because I clicked sample. Okay. Everybody all right with that one? Okay, so sample standard deviation, it says round to 2 decimal places. Please, please pay attention to the rounding directions. Okay. Everybody good with that? Okay. Question 6 is an opinion question. I'm going to ask you the question. Suppose you want to invest money safely. Okay. So for a minute, imagine that you're not the age you are now. Imagine you're like a year away from retirement. Okay. And you need to be able to draw the money out of your investment in a year. Okay. So suppose you wish to invest money safely and are trying to decide between stock options in 2 companies. The average rates of return are the same for both companies, but one company has a much larger standard deviation of its rates of returns. Which company should you invest in if you want to invest safely? Okay, so I'm asking you to participate. What's your answer to number 6? Okay, what's your answer to number 6? Okay, just put your answer in the chat. And again, if you just want to type the word smaller or larger, that's fine. Okay, but give me some feedback, folks. I'm asking you to participate here. Anybody else have any opinion? Okay. How about the rest of you? We've got 13 people on. Okay, everybody's saying smaller. Okay, and that's correct if you want to be safe. Okay, because what does the smaller standard deviation mean? Okay, so what does the smaller standard deviation mean about the rates of return? Okay, suppose we're looking at rates of return over a 10-year period. What does the smaller standard deviation mean? Okay, anybody want to either unmute and chat with us or type it? So I'm asking you why you picked what you did. Your answer is correct, but why is it correct? Yeah, okay. There's less variability in the return. So if you have an average, realize that in some cases, you could have a wildly high rate of return, and then the next year you could have a negative rate of return, okay, where you actually lose your investment, your principal, some of it, okay, and they average out to something in the middle, okay. That's with a large standard deviation. If you have a smaller standard deviation, there's less swing around your average value. Okay, so if you are planning to draw on this investment sometime soon, you want the stability of knowing, hey, I'm not going to lose my actual principal that I put in here. Okay, I may not make as much as if I had a wildly variable rate of return, but I won't lose it either. Okay, so the answer is, yeah, less variability in the rate of return. Okay, and again, this is totally linked to your appetite for risk. Okay, if you have plenty of time to recover from downturns in the stock market, then a lot of people are aggressive. Okay, they'll put in as much as they can afford to lose. Okay, but put them in very aggressive investments because there's enough time to recoup that. Okay, but the closer you get to needing the money from your investment, whether it's to buy a house, to pay for college for a child, or to retire, okay, you'll find there's less appetite for risk because you're kind of depending on a certain amount being there. Okay, So again, an opinion question, but with a right answer. Okay, so question 7 is saying about 1% of the population has a particular genetic mutation. 400 people are randomly selected. Again, they're not saying from this population. And I'll put it this way, from this very large population. Okay, so we might be saying this is the population of all people living in the United States. So some 330 million people, okay? And we're selecting a sample of 400, okay? Find the standard deviation for the number of people with the genetic mutation in such groups of 400. So across all of these samples of 400. Okay, so what you want to take away from this problem is, okay, how did I pick people? I chose 400 out of a very large population. I'm basically not, the fact that I'm choosing such a small sample from a very large population is not going to affect the probability of me picking people with the mutation, okay, because the population is so large. So I can treat this as a binomial experiment. Okay, so I'm going to select populations of 400, a whole bunch of them. Okay, and because the population is assumed to be large enough, the fact that I picked 400 out of it, okay, without replacement, is not going to affect the probability of me picking someone with a mutation. So if I treat this as a binomial experiment, then this is my p-value, probability of success. Success is picking someone with a mutation, okay? Here's my n, okay? And you might remember we had some formulas for the mean and the standard deviation of such of a binomial population, a binomial experiment like this. It's actually of a binomial random variable because we're taking multiple samples of 400. The mean is just n times p. They didn't ask us for that. They asked us for the standard deviation. And that's the square root of n times p times 1 minus p. Okay, so this is a matter of remembering the formula. Okay. And then I'm just going to plug in my data. My n is 400. My p is 0.01, 1%. And my 1 minus p is 0.99. Okay, and then that's something you just do on a calculator. And I'll bring up the TI really quick. All right, so square root. And then you type in 400 times 0.01 times 0.99. Enter. Okay, so 1.9899. Okay. And again, they're not giving me any rounding directions. So usually when they do that, I'll basically just round it to a bunch of decimal places. So how about 1.99? They didn't tell me what to round it to. So I'm rounding it to the nearest hundredth. Okay. Everybody okay with number 7? Okay. Find the standard deviation of this probability distribution. Okay. from our notes, we have the standard deviation of this probability distribution is the sum of the data values minus the mean squared times the probability of that data. Okay, and that's what we have. Now, if you're doing this by hand, first you've got to figure out X bar, which is the expected value. Okay, and you might remember that as being the X value times its probability. Okay, and then you've got to do X minus X bar squared. Personally, I mean, I could do this on a TI. I'd use probably 4 out of my 6 lists. Okay, but this might be easier to do in Excel. Okay, so let me just bring up Excel. All right, and I'm going to kind of put it over here. I'll put the table over here. All right, and my values for X are 0, 0, 1, 2, and 3. Okay, and the probabilities are 0.05, 0.3, 0.05, and 0.6. Okay, so again, just checking, these add up to 0.1. These together are 0.9. 0.9 and 0.1 is 1. Remember, my probabilities need to add up to 1 for this to be a valid probability distribution. Okay, so the first thing I need to do is find my expected value. Okay, so the first thing I'm going to do is multiply X times P of X. Okay, multiply each value by its probability. So that's going to be this times that. Okay, and then I'm just going to pull down to get it for each one of those, right? So you know how when you pull down, you're going to get it for each pair of cells. Okay, so then I have my expected value, okay, or X bar. And again, I can't do X bar here easily. Okay, so that's going to just be the sum of all of these. Okay, so there's my expected value. It's 2.2. Okay, now again, my formula for the standard deviation was square root. Okay, and it was the sum of X minus the expected value of X squared times the probability of X. Okay, so I'm trying to just copy this over. So first I need to, if you look at this, starting on the inside, I need to take the X value minus the expected value and then square it. Okay, so this is going to be X minus expected value of X. Okay, now remember, when I drag this down for the whole row, I want to make sure the expected value of X is not changing, okay, because that's fixed at 2.2. So what I'm going to do here is I'm going to say equals, take my X value, and then when I subtract the expected value, I'm going to make sure to put dollar signs here, okay? So I actually want $C $7. That anchors it to that cell. Okay, so that's that difference. And then I'm going to pull it down. And again, just so to check, see that the $C, the X value is changing, but not the $C, $7. Okay. Next step is to take this difference and square it. Okay, so that's what I want to do here. So here I have to basically say, take this. I am not sure about that. So let me put it in parentheses. Okay, I'm putting it in parentheses because some of the values are negative. I want to make sure I get all positive squared values. All right, so that's them squared. Okay, next thing I need to do is I need to multiply that by the probabilities. Okay, so I'm going to make this slightly larger. I'm going to copy this. And then multiply that by P of X. Okay, everybody see how I'm kind of like breaking the formula down from the middle outwards, okay? So now I need to take this and multiply it by P of X. Okay, so that's going to be this value times P of X. All right, and then I'm going to scroll down. Okay, so it does it for the whole distribution. Okay, and now I'm finally to the point where I want to sum this up. Okay, and this should be my standard deviation when I get here after I take the square root of it. Okay, but let me sum it first. Okay, so 1.06. All right, and the last step is to take the square root. Okay, and basically in Excel that I believe is SQRT of this. Oops. Nope, not a range. Don't want a range. Just this one number. Okay, so after all that, okay, this is doing the formula in steps. I get 1.03 for my standard deviation. Okay, and again, this was question number 8. I will upload that with the notes so you can see how I'm doing the actual calculations. Okay. So again, this took long because I was talking my way through it. Again, you don't need the headings if you just have the formula in front of you. You just move over a column to do every operation. Okay. And again, the formula that you do need for this one is the one from the notes right here. Okay, so we got sigma equals 1.0. Okay, again, use Excel for this one. Okay, this can also be done with lists in the TI-84, but it's a little more tedious. If you remember, I showed you with the lists in the TI-84, you can do one operation on everything in one list. It's kind of like doing a function on a column in Excel, and then you can store it into the next list over. That's like the next column in a spreadsheet. Okay, so the TI-84 is operating like a primitive spreadsheet. Well, why not use the real thing? Okay. Anybody questions on 8? Questions on 8? Everybody good with that one? Again, it's just steps, okay? So it's a matter of keeping track of the steps. Start on the inside. The innermost thing here is the difference, then the squaring, then the multiplying, then the sum, last thing is the square root. So start in the middle and work out. Okay. Question number 9, is this a probability distribution? Okay, what do you need to check for it to be a probability distribution? I'm asking for feedback. What do you need to check? There's 2 things. Anybody know one of the 2 things? Yeah, all the probabilities have to be between 0 and 1. Right? So no negative probabilities or no probabilities greater than 1. And then the sum of all the probabilities has to equal 1. Okay, those are the 2 things you need to check. Well, looking quickly at this column, I'm not seeing anything that's problematic as far as individual probabilities. So all I need to do is check the last part, check that 0.3 plus 0.05 plus 0.3 plus 0.35. Okay, what does that equal? Okay, if you take a look at 0.05 and 0.35, that's 0.4. These add up to 0.6. So yes, this is indeed equal to 1. So then I can say, yes, it is a probability distribution. Okay? All right, please don't assume that if you get to question 9, it's always going to be yes. Okay, these questions are set up to randomize the data. Okay, so some will be and some won't be. Okay, so please check. All righty. Question 10 is a uniform probability. Okay, they tell you it's uniformly probability. The time it takes you to wash dishes is uniformly distributed between 8 minutes and 17 minutes. If you remember, uniform probabilities have this A and B that are the endpoints of the interval you're interested in. Okay? And then they ask you, what's the probability that washing dishes tonight will take me between 10 and 12 minutes? Well, uniformly distributed, let's do the density function for that. That's 1 over B minus A. Okay, this is in our notes. Okay, so this is going to be 1 over 17 minus 8. Okay, so my probability distribution is 1/9. Okay, so here's kind of what your distribution looks like. All right, you're starting at 8 and you're going to 17. Your probability for all of these is 1/9. Right, so the height is 1/9. And what you want to find is you want to find the area between 10 and 12. Okay, so that's what you want to find. Okay. So again, the way you do this to find the probability, it's going to be your endpoints, right? Let's call them, well, let's just use 10, 12 minus 10. Okay, that's telling you how many units you have. Think of breaking this big rectangle into units that are 1 wide. Okay, how many of them are there? Well, in between here, there's 2 of them, right? So you've got 11 here. So you've got 2 of these units. And then you're going to multiply that by the probability. Okay, so that's going to be 2/9, which is approximately equal to 0.22. So you're just finding the proportion of your rectangle, your overall rectangle, that's shaded. Okay, this is 2 out of 9 blocks. Okay, if you want to see all the blocks, here's 9. Then you have 12. Here's 13, 14, 15, 16. There are the 9 blocks. Okay? And you're shading 2 out of the 9. That's all you're looking for. Okay? Because remember, probability is the area under the density function curve. Okay, probability is the area. So you want the area between 10 and 12. Okay, that's all you're doing here. Okay, questions on that one? Okay, let's take a look at the next one. Right here, looks like we're building a probability distribution. Let's try that. Okay, suppose you're offered the following deal. You roll a 6-sided die. If you roll a 6, you win 13 bucks. If you roll a 4 or a 5, you win $2. Otherwise, you pay $5. Okay, so basically, it doesn't seem like I'm paying to play. Okay, so again, they're not telling me it costs $5 to play the game. They're saying you're going to step up to the table and be given a die. You roll a 6, you get $13. You roll a 4 or 5, you win $2. Otherwise, if you don't win a 4, 5, or you roll a 4, 5, or a 6, you pay $5. Okay, so let's figure out what we can actually win. Okay, this is list X as the profit from smallest to largest. Well, I could lose $5 if I roll a 1, 2, or a 3. Okay, if I roll a 4 or a 5, I could win $2. And if I roll a 6, I win 13. And then all I need is the probabilities for each of these. Okay, well, losing $5 happens if I roll a 1, 2, or 3. Okay, that's 3 out of 6 possibilities. Okay, I get a $2 payout if I roll a 4 or a 5. Okay, that's 2 out of 6. Okay, and the $13 giant payoff is only if I roll a 6. There's only one of those. Okay, and again, you can see it's a probability distribution because 3 plus 2 is 5 plus 1 is 6, 6. Okay, so there's the probability distribution. Okay, and now they want us to find the expected profit. Well, that's the same as expected value. And remember how you do that is you just multiply the outcomes times the probability. Okay, so that's something I'm going to do on a calculator. All right. And if I do that, I should get an expected value, a positive expected value of 0.33. All right, so 0.33 would be what I would put in there. Okay. Interpret the expected value. All right, well, expected value, remember, this is from the point of view of the person playing, because this was my profit if I play the game. Okay, not the person running the game. Okay, so if I play this game many times, on average, I'll win about 33 cents per game that I played. Now, again, I'm either going to lose $5, win $2, or win 13 on any individual game. So it's not this answer. Okay, it doesn't predict the outcome of any particular game. It's an average. Okay, based on the expected value, should you play this game? Okay, and again, This is kind of opinions, okay? But it's asking you to interpret what the expected value means to you. And I would say, well, it's not a fair game, but it's not fair to the person running the game. Because eventually the person running the game will be out of money. Okay, particularly if word gets around that this game has a positive expected value for the player. Okay, since the expected value is positive, you are very likely to come home with more money if you played many games. Does that guarantee you'll come home with more? No, it means on average. Okay, you may wind up in the hole before you wind up winning. Okay. So again, this is the answer they're looking for. Again, on these problems, make sure you look at the hint, okay? If there's a hint provided, okay? So please, again, pay attention. Okay. Question 12. Okay. A manufacturer knows that their items have a normally distributed length with a mean of 16.6 inches and a standard deviation of 2.9. Mean, standard deviation. Okay, and this is for the population. If one item is chosen at random, what is the probability that it's less than 9.3 inches? Okay, so smaller than. Okay, and again, I've put information here that will help you answer the problem. Okay, so again, I'll do some of these. I'm not going to go through all of them because there are a lot of normal distribution questions here. Okay, but I just want to show you how to do some of them with the normal CDF on the TI-84, as well as using the normal distribution calculator built into the course. Okay, so let's do the TI first. Okay, so turn it on. Okay, remember, these are on second VAERS distribution, so second VAERS. I'm always going to use normal CDF. And again, the lowest value I'm interested in, there isn't any. Okay, so I'm going to leave my negative infinity in here for my low value. My upper value is 9.3. Okay, that's the largest item length that I care about. Okay, and I'm interested in everything less than that. Okay, and then I have to put in the mean and the standard deviation. So 16.6, standard deviation 2.9, and run it. And I get a probability of 0.0059. Okay, do your normal probabilities to 4 decimal places. Okay, do your normal probabilities to 4 decimal places. That's generally standard with normal probabilities. Okay, so that's how you do it on the TI. Let's try this next one. A manufacturer knows that their items have a normally distributed lifespan with a mean of 8.3 years and a standard deviation of half a year. If you purchase one item, what is the probability it will last longer than 9 years? So here you want X is greater than 9. Okay. If I were to do this on a TI-84, I would have to fake out positive infinity with 1E99. Okay. But I'm going to use the normal calculator I built into the course for this one. Okay, so if I go back here to my course, right, back out. Okay, and again, here's my normal probability calculator. Right here, I have to put the mean and the standard deviation in here. Here, my mean was 8.3. And my standard deviation was 0.5. Okay, and notice it'll put everything on the curve correctly. And I'm interested in having the probability that I pick something that lasts longer than 9 years. So I'm going to click above and put 9. All right, so I'm interested in the part of the curve out here. Click recalculate. It'll show me the area that it's finding under the curve. This is where 9 would be. And my probability is 0.0808. Okay, everybody okay with both normal calculators? Okay, so basically, if you use the online one, you don't have to worry about faking out positive or negative infinity. Okay, everybody all right with the normal calculators? Okay. I'm going to skip question 14 because question 14 is more of the same. The only difference with 14 is it's asking you to find the probability between two values. So a particular fruit weights are normally distributed with a certain mean and a certain standard deviation. If you pick a fruit at random, what's the probability it's between? Okay, so here's what I want. The probability that X is greater than 594 and less than 617. So you just pick between here. Okay, for the online calculator. On the TI, this is your lower, this is your upper. Okay, so no infinity. Okay. Let's look at number 15. It says for standard normal distribution, find C if the probability that Z is less than C is 0.6096. Now here they're giving you a probability. Right, which is 0.6096, asking for a Z-score. Okay, so this is the reverse of the normal calculator. The normal calculator gives a Z value or can calculate a Z value from the scores and asks you for a probability. Okay, so here you need an inverse normal calculator. Okay, so I have on my TI, I have inv norm. Okay, on the TI. And then there's basically an online one, and I'll show you that one too. So let's do inv norm first. Okay, inv norm works solely from the left to the right. So the fact that this is asking me for the probability that Z is less than C, I don't have to worry about subtracting from 1 or anything like that. Okay, this is exactly what inv norm gives me. So go to distributions. You can see inv norm is number 3. Okay, area is the same as probability. So put your probability there, 6096. Okay. And again, they said standard normal. Okay, so that basically is telling you your mean is 0 and your standard deviation is 1. Okay, so this is set up to go just the way it is. And this gives me a C value of 0.278, and let's make it a 3. Okay, and that's a Z-score. Okay, so they're saying 60%, okay, of the area in a normal distribution is below the Z-score, positive 2.783. 60% of the area, okay, is below that Z-score. Okay. Now, if I do this with my online calculators, okay, I don't want my normal distribution, I want inverse normal. So again, I need to go back to my course and find that. So again, can't get it out of the way. All right, so inverse normal is also in week 13 as well as in the online calculator section. So I'm going to click on that. And what's nice, again, this will show me what it's talking about. I want an area of 6096 with a mean of 0 and a standard deviation of 1. And I want the area that's below that. Okay, so I click below and it gives me 0.278. Okay, so this is the z-score, 0.278. And here's the 60.96% of the area. Okay, and you can see that's definitely more than half the area under the curve. Right? It's more important to understand what these calculators are showing you. Okay, which is why I like this one with the picture. Okay, so this is saying 60.96% of the area under the curve is below z-score 0.270. That's what that means. Okay. Everybody good with that? Anybody questions about that? Okay, we've got a few more questions to go through. So I'm going to go back to the notes. Right. In a normal distribution, a data value located 0.8 standard deviations below the mean, okay, has a standard score, a z-score of negative 0.8. Okay, because remember, on a standard normal distribution, okay, the standard deviations are the same thing as the z-scores. Okay, so if I'm saying I'm 0.8 standard deviations below the mean, that's like saying I have a z-score of negative 0.8. Likewise, if I have a data value located 1.7 standard deviations above the mean, that has a z-score of 1.7. Okay, and in a normal distribution, the mean has a z-score of 0. Okay, the mean has a z-score of 0. Everybody okay with that one? Okay, that's talking about relative positions of things in a standard distribution. Questions about 16? All right, let's look at 17. 17 is asking you to use the empirical rule. Okay, and it says a set of exam scores is normally distributed with a mean of 74 and a standard deviation of 6. Okay, here's 74. Whoops. Okay, and the one standard deviation above, I'm going to add 6 to that, so that'll be 80. Another standard deviation will add another 6, would be 86. Okay, and 3 standard deviations above the mean would add another 6, so 92. So this is plus 1 sigma, plus 2 sigma, plus 3 sigma. Going the other way, I'm going to subtract 6. Okay, so 74 minus 6 is 68. Minus another 6 is 62. And minus another 6 is 56. Okay, so I'm showing you the standard deviations or the z-scores associated with these scores in my distribution. Right, then I have this. Here's my curve. And you have to remember, again, the empirical rule. The empirical rule says what? It says 68% of the data is between positive and -1 standard deviations above the mean. 95% of the data is between -2 and +2 standard deviations. And almost all of the data, or 99.7, is between -3 and +3 standard deviations. Okay, that's what the empirical rule tells you. And now they're just asking you for the scores of the cutoffs. 68% of the scores are between, well, this black box, between 68 and 80. Okay, that's -1 and +1 standard deviations. 95% are between 62 and 86. That's -2 and +2 standard deviations. And last but not least, 99.7 are between 56 and 92. Okay, so that's -3 standard deviations +3. Okay, everybody okay with the empirical rule? Everybody good with that one? Okay. Questions on that one? Okay. All right, the last couple of questions are pretty straightforward. Okay, interpreting z-scores. Okay, so remember, positive z-scores are above the mean. Negative z-scores are below the mean. The mean itself has a z-score of 0. Okay, so if the data is weight, the z-score for someone who is overweight, and what that means is above the mean weight, okay, so you have to do a little interpretation. That would be a positive z-score because they're above the mean. If the data is IQ scores, an individual with a negative z-score would have a low IQ compared to the rest. Right, of the test takers. We're not saying whether the test is valid. We're just saying according to that distribution, what does the negative z-score mean? If the data is time spent watching TV, an individual with a z-score of 0 would be exactly average. Okay. Okay, mean has a z-score of 0. If data is annual salary in the US and the population is all legally employed people, the z-scores of people who make minimum wage, okay, annual salary, okay, minimum means less than the mean, okay? Minimum means less than average, right? So that would be negative. Okay, if you're making the minimum allowed amount that you can be paid. Okay, everybody understand how to interpret those? Yeah? Okay. Last two questions. The height of adult men in America are normally distributed with a mean of 69.2 inches and a standard deviation of 2.64. And we have, again, women with a mean of 64.2 and 2.55 as their standard deviation. Okay, so I have the men and the women. Okay, I'm using an M to denote the statistics for men and the W for women. If a man is 6 feet 3 inches tall, guys, use an online calculator to convert it to inches. Okay, because you have to convert it to inches. So just ask, go from feet and inches to inches. Just again, 6 feet is 72 plus 3, so he's 75 inches tall. Okay, there is a z-score calculator in the course if you want to use it, but it's super easy to do z. Again, I'll use the population statistics here. Okay, so your X value minus the mean. Okay, divided by the standard deviation. Make sure you use the right one. This is for men. Okay, and again, this would give you a value of about 2.20 for his Z-score. Okay, he's tall. Okay, he's taller than average for sure. Okay, now we want to take a woman who's 5'11". 5 feet is 60 plus 11, that's 71 inches. Okay, so convert the heights to inches because that's what your distribution gives you as the means and standard deviations. Okay, so a 71-inch woman and a mean is 64.2. I'm using the women's data now. Okay, I'm computing her Z-score. Her Z-score comes out to be 2.67. Okay, now they ask you which one of them is relatively taller, relatively to the rest of their distribution. Okay, so what they're actually asking you is, yes, they're both tall people, but is he exceptionally tall for a man or is she exceptionally tall for a woman? Okay, and the answer is she's exceptionally tall for a woman because her Z-score is higher. Okay, what that tells you is compared to the distribution of women's heights, she's further from the mean. So your answer would be the woman. And again, please realize this is a randomly generated question. It won't always be the woman. Okay, so please make sure to actually do the calculations. Okay, see who has the higher Z-score. Okay. All right. Again, the rest of these, again, we have a variable with a mean of 22 and a standard deviation of 3. Again, here's the Z-score calculation, X minus the mean over sigma. Okay, determine the Z-score for 27. So put X for 27 minus 22 over 3. That gives you your Z value. Okay, and this gives me 1.67. Okay, for 18 minus 22, notice here I'm going to be getting a negative Z-score because 18 is below the mean. Okay, this gives me negative 1.33. Okay, what value of X has a Z-score of this? This is done a little bit backwards. This is like saying X minus 22 divided by 3 equals 2.67. Okay, so again with these, okay, I just had to calculate the Z value. So let me show it to you like this. Okay, here I was looking for Z. Okay, here I'm looking for X. All right, so you need to do a little bit of algebra. Okay, multiply both sides by 3. Okay, that'll give you X minus 22 equals 2.67 times 3. Okay, add 22. All right, and then you just need to evaluate this on a calculator. Okay, and if you evaluate that on a calculator, you're going to get 30.01. All right, so again, please pay attention to what they're looking for. In the first two, they're looking for Z. Here, they're looking for X. All right, so again, here they're saying what X value has a negative Z-score of negative 0.3. I'm going to do it the same way. Multiply both sides by 3. Okay, and then add 22. All right, and evaluate that on a calculator. Okay, you can see since it's got a negative number times 3, it's going to pull value away from the mean. So I should get a value less than 22, and I do. I get 21.1. Okay, last one's a gimme. It's real easy. What value of X has a z-score of 0? That's always the mean. Okay? Everybody okay with this? Anybody have questions on it? Any questions on any of these? Are we good? We're going to come back to the meeting. Okay. Anybody have questions at all about the exam or the practice exam or any of that stuff?